So we're now in my GitHub repository for the EX35 case study, which you can get in the Java 8 folder in my live lessons GitHub repository in the EX35 project. And let's start here by taking a look at the main driver program. And this example is going to show how you can overcome the limitations with flatMap, which doesn't scale with Java parallel streams. And it's going to show a couple different ways to do this. One by using map, reduce, and stream concat, and the other using mapMulti to fix these problems. And we're going to do this case study both for streams of reference types, which is just the good old Java stream type interface, and with primitive types, which are the int stream mechanism. And there's slight differences between the way that they're programmed, and I want to give you a sense of how they work and whether it makes any difference to use the primitive types versus the reference types. So here's the main entry point of the test program. It starts out by printing how many cores that we've got. And I had run this earlier, so you can see that this has 10 cores. And the reason I ran it earlier because I had a very large number of values I wanted to do, so I had 100,000, so it took a while to run, so I just pre-ran it. And then we come in here, we parse the arguments, which we can use to do things like set how many iterations we want to make. So if you take a look here, what it had looked like when I ran it originally, it had 100,000, and we had turned off debugging. But then for the simple example I'm going to show you here, interactively, we're going to make this much smaller, so it won't take as long, and we can look at the output more thoroughly. And then we ran two tests, one that used the int stream mechanism, and the other just uses the stream mechanism. All these tests are going to be timed. We're going to do some warm-ups. We're going to do some timing. And then we're going to go ahead and get the results here. And these results will then print out how things ran. And not to give away the suspense too much, but this is what it looked like when we ran it for 100,000 items. The mapMulti solutions did the best. I was actually a bit surprised by that. That's cool. So mapMulti runs very well, and both for using reference types and for primitive types. Then the version that uses map and/or map reduce concat also did pretty well. You can see they didn't do as well as the mapMulti, but they didn't do very bad. And then, as you might expect, because there's no parallelism whatsoever here, or very limited parallelism, test flatMap took a lot longer time to run for both the int stream and the stream tests. So that's just kind of giving you a high-level view of what the results are. And then the other thing I'll show you here just briefly, when we run these tests, it's going to check to see whether or not they run sequentially or in parallel. And you can see that the flatMap tests run sequentially, and I'll show you how I know that when we get into the details of the code. But the other tests run in parallel, which of course accounts for the fact that they run a heck of a lot faster. So here's the run test method. There's a run test method that everybody calls. It is passed a runnable and the name of the test. First thing we do is we garbage collect everything so that we start with a pristine, even playing field with all the memory collected. And then we go ahead and we run the test using our time run method. I've talked about this many times, but just for completeness, the run timer class basically keeps this results map, and the results map is then used when we run this in order to start the timer, run the method under test, stop the timer, and then store the test name into a map with the execution time recorded. So we know how long that particular method, that particular test took to run. All right, so that's essentially that. Here's the main driver methods: run int tests and run stream tests, or run int stream tests and run stream tests. And you can see what I'm doing here. I'm going to call the run test method that we saw that does the timing, and I'm going to pass in method references to the method under test, and I'm going to pass in the name of this so it can get recorded in the map with that name. And you'll notice I do a warm-up first, and then I actually run the test again, and that's because you need to warm these things up. Otherwise, you have cache issues in the sense of the instruction processor cache. And so we warm up the flatMap test, we warm up the map test, we warm up the mapMulti test, and then we run those things too. And then we do the same thing here for the stream tests. So these are the ones that use the reference types, not the primitive types. Basically exactly the same idea, just different implementations. And then you can see, of course, as we just talked about, which ones perform the best. So that's a quick walkthrough of the overall part of the program. There's other things here that I'm not really going to talk about in detail, like the options class, which is pretty simple. But there is something else that we're going to talk about now called parallel checker. And I'm very proud of this. This took me a while to figure out. So what we're trying to do is we're trying to figure out whether or not code that's being called is indeed running in parallel. It's kind of an interesting thing to try to do. And I'll show you specifically how we do this later. But first, let me show you the basic idea of this. Because if you can make sense of this, then the other parts of the test make more sense. So I have 3 static final ints whose values are chosen carefully. One is called S for static intermediate result, which starts out with 0, S sequential result, which starts out at 1, and S parallel result, which starts at as 2. So they all have to be 3 distinct values. And you'll see as we do this that we want to have the intermediate results ignored. All we care about was, did this operation, this inner stream, run in parallel or not? And so those are the values we're going to use. And other parts of the code will check those values to see whether they ran in parallel. So now let's see how on earth we can determine whether or not a piece of code is running in parallel. And so this is going to be a method called check inner stream thread IDs. And the way it's supposed to work is if this inner stream, if the thing that's calling this guy runs sequentially, then when it finishes, the thread ID that it ran in will match the thread ID of whatever thread called it, which means it wasn't running in parallel. However, if the inner stream runs in parallel, then its thread ID most likely won't match the outer thread ID because it'll be running in a different thread. So that's the basic idea. So we're going to pass in here how many iterations we want to be taking place. You'll see why we use that in a second. We pass in an atomic integer, which is the inner thread ID counter, and we use an atomic integer so it works correctly if it's incremented in a multi-threaded environment. We pass in something called a thread map. You'll see what that is. And then we also pass in the outer thread ID. So these are the 4 parameters that are passed. And this explains kind of what's happening here. And what we're going to do, this is really funky. So we want to be able to figure out how to initialize this thread map so that the first time it's used, we can set its value to something that we control. And here's how we're going to do it. We're going to say, hey, thread map, passed in as a parameter, put if absent the current thread ID, and if this is the first time in, make the value be an atomic integer who starts out with a value of 1. So put if absent is a super cool check if act method, atomic check if act method, that checks to see if this is the first time in, and if so, it atomically creates an instance of an atomic integer that sets a value to 1. And so we're going to keep track of the current thread ID in order to know whether or not this thing is running in a different thread than its caller. So we get back an atomic integer, and then we check to see what came back from put if absent. If we got back null, that meant it was the first time in. So we have this thing initialized to 1. We're fine. However, if it was not the first time in, we're going to increment the value by 1. So this said we know that this is the next time we've been called. So then what we do is we check to see, is the inner thread ID counter, when incremented by 1, and we do this atomically again, of course, equal to the maximum iterations. That means, have we finished this inner stream processing phase? And if that's the case, this is the final iteration for this particular inner stream. And now we're going to do some really cool magic. Check this out. So what we're going to do is we're going to check to see how big is the map. And if the map has only 1 entry in it, and that entry contains the outer thread ID's value, that meant that everything ran sequentially. So we set a Boolean that says was sequential. If the map has more than 1 entry in it, and that entry is not the thread ID, then the outer thread ID, then we know things ran in parallel. So we then print a little diagnostic if we're in debugging mode, saying what happened and whether it was sequential or parallel. And then if it was a sequential, if at the end of this iteration, everything ran sequentially, we return S sequential result, which is the value of 1. Otherwise, we return S parallel result, which is the value of 2. And if it was not the end final iteration, we return the intermediate result, which will just be ignored. So this is how we're going to be able to figure out whether things are running in parallel or not. So that's the method that does this. So keep that in mind. And when we look at the actual implementation of the other parts of the code, this is the workhorse that figures out whether something ran in parallel.